We'll get started in a minute. Started in a minute. So let me just get this out to everybody on their mind. And then we will get going. So we'll get started soon. I'll let a few people start joining. Right now we got one person watching. If you have any questions, text me on Remind. I'm just going to go over some of the castle learning. So just let me know if you got a question, and we'll do what we can. It'll probably lag behind a little bit, so I'll try to take into account that's happening. I'll try to talk ahead of what I'm going to write, though it could be a little awkward. I'm not going to go through every single one on the castle learning because there's a lot of these. But I'm going to pick and choose a few of the big ones. And I'll get started in about a minute. I'm going to get a drink of water and a couple other things, and then we'll get going. All right? All right, so all four of you, you're going to notice that it might lag behind a little bit. You'll probably hear my voice before you see what I write. I can already tell from the video that I'm watching of me. So I'll try to write before I talk so that hopefully it catches up with itself. If you are tuning in, this is a review for my Regents class who has a quarterly tomorrow. So if you took your quarterly today, you can go away. All right, so I'm going to start with protons, neutrons, and electrons. Protons are positively charged. Electrons are negatively charged. And neutrons have no charge. So, when you look at this, if it was asking you what the charge of this was, it would be 0 because your protons equal your electrons. So just keep that in mind. If the question was asking about the mass, you would add the protons plus the neutrons, and that would give you your answer. Because the protons weigh 1, the electrons weigh 0, and the neutrons weigh 1. So mass is protons plus neutrons. Charge is all about protons and electrons. Let's make up a few examples. Let's say, instead of the problem having 26 protons and 26 electrons, let's pretend that it had 30 electrons. How would you get the charge? Electrons are negative. Protons are positive. When you look at this relationship now, since you have 4 more negatives than you do positives, your charge would end up being -4. And I know that's confusing because you're like, I have more electrons. Well, if you have more electrons, you're going to be positive or negative. If you have more protons, you're going to be positive or negative. They can't both be positive or both be negative. So if you have more negatives, you're negatives. Or you're negative. If I were to change it away from the protons now being 30 instead of the electrons, you would now have an excess of positive charge. Precisely 4 more positive charges. So your overall charge would be +4. When you have something that is charged, we call that an ion. So you would have an ion in this case. All right. Quick refresher on protons, neutrons, and electrons. In terms of where they are, your protons and neutrons are in your nucleus, and your negatively charged electrons are orbiting around the outside. Since there's no electrons in your nucleus, we would say the nucleus has a positive charge because only the positively charged things are in the nucleus. There's no negatively charged things. When you're looking at a mixture problem and you want to identify what is in the mixture based on your spectral lines, read it from the top down. So if I look at element A here, I would say element A is in the mixture. If I were to look at element D is not in the mixture. If I were to look at element X, I would say element X is in the mixture. And if I were to look at element Z, I would say element Z is not. So read it from the top down. Don't read it from the bottom up. Remember, when you see vapor pressure, you're going to think table H. So when you see vapor pressure, you're going to think table H. Some of these things we went over in class, so I don't want to stress them too much. And again, I'd like you to do some of these on your own. I just want to go over some of the big ones, like 18. If you don't take the time to memorize the kinetic molecular theory, take the time to memorize the kinetic molecular theory. So what is true here? I think it would be easiest to evaluate this and correct the ones that are false. One is false because then when they collide, they do transfer energy. And remember, this is all about gases, an ideal gas, a model gas, where you're at a high temperature and a low pressure. So just keep that in mind. 2 is true because it is. They move in random, constant, straight line motion. 3 is false. 3 describes a solid. They're not arranged in any regular patterns. They're more so arranged randomly. So you can't really predict their arrangement. They fill the container. Again, this is about a gas. Four is false because they are actually separated by large distances. We assume they are very small and that they are very far apart. So just keep those in mind for tomorrow. I'm going to go grab me some coffee. I'll be right back. Because I got to do this again at 8 o'clock for my other class. Not too big of a cup of coffee now, Mr. G. You don't want to be up all night. 7 people watching. Love it. Love it. Welcome. Welcome and thank you for tuning in. Again, if you have a question, I don't have YouTube comments turned on because it's just easier for me to track this on Remind than it is on YouTube. So shoot me a line, and I appreciate some people from my 4th block. They just want to tune in. Is it quality coffee? I don't know, but it's a warm cup on a cool night. We have snow in the forecast, so it's going to feel nice and cozy. Quality, mediocre. All right, moving on. So these heat equations we did a lot of in class. Particle diagrams. I feel like we haven't talked about those. I'm going to ignore the question again and just go over these individually. Now, can you por favor go over one of those crazy hard ones? If you're tuning in from my 4th block, again, to reiterate, you took your quarterly already. I appreciate you giving me the views. Doesn't help me that much. If you're viewing from my 3rd block, feel free to tune in. I'm going to go over the ones specific for your class at 8. If you're tuning in from my 1st block, welcome. Your quarterly's tomorrow in the morning. Please be there. That's all I ask. All right. If you look at this particle diagram, first thing I would say is that this is a mixture because you see 2 different things separated from each other. Second thing I would say is that you have a mixture of elements because they are bonded to themselves. It's the same element bonded to itself, which makes it an element. More specifically, it's a molecule, but the Regents and June would classify these as elements because they are. You don't see anything different. All right, let's look at this diagram here. When I look at this diagram, I would classify it as a compound. And I would say that because they are two different things bonded together. They look like a bunch of Mickey Mice. Bunch of Mickey Mice. And it's not a mixture because they're all the same compound. They're all one white. Usually we call this water because this is what water would look like. One white oxygen bonded to two black hydrogens. Diagram 1 I would classify as a mixture because we have one thing there that is an element, and the Mickey Mouse again, which is a compound. So we have a mixture, specifically a mixture of elements and compounds. When you're drawing them in terms of phases, so let's talk about phases. A solid is ordered and structured and arranged in a pretty linear kind of pattern. So it's going to look something like that. A liquid just kind of takes that solid and disperses it across the bottom. So think of it like pouring water into a cup. It doesn't fill the whole cup unless you want it to, but it spreads across the whole bottom of the cup and then rises up as you add more water. A gas is the easiest one to kind of do. A gas is crazy. A gas has high entropy, lots of craziness. So it would fill the entire container, whatever gas you have. When you see a dash, that's the mass. Just keep that in mind. Dash is mass. Dash is mass. Let's do all the graphs. All the graphs for gases. Pressure versus temperature is a linear relationship, proportional. They go up and down together, so it will look like that. Temperature and volume is the same thing. They go up and down together, so it's going to look exactly like the pressure versus temperature graph. Pressure and volume are different. As pressure goes up, volume goes down, and vice versa. So it ends up looking like what you see there. As pressure goes up, volume goes down. Those are the graphs. Generally speaking, when you see an average atomic mass, take the percent times the mass, take the other percent times the mass, add them together, and then divide them all by 100. So it's going to be a lot easier if you do this in like one straight line. Like I just ran out of room, so it looks a little sloppy. But just percent times mass plus percent times mass times 100. Please keep in mind that kinetic energy, more specifically average kinetic energy, is the same as the temperature. So the higher the temperature, the higher the kinetic energy. You may or may not see a trick. If they are in different units, make them all the same unit. It's easiest to just convert to Kelvin. So just add 273 to your Celsius units, and then they're Kelvin. Make sure you take your time on all the math ones. Sublimation is solid to gas. So that's what we're looking for with sublimation. Endothermic is heat entering. Heat entering. So, when you see liquid to gas, I would say that it's endothermic because it's heating up. If I see gas to solid, that's cooling down. That's exothermic. I would say the same thing for liquid to solid. That's freezing. That's exothermic. The gold foil experiment. That was Rutherford. So, 1, 2, 3, and 4 are all true things discovered at some point. Which one was specific to gold foil is the question. So, gold foil discovered two things. One, the atom is mostly empty. He fired a bunch of particles and noticed that all of them passed through. Two, some of those particles were bouncing off, which means they were hitting something, and he said those things were hitting something in the middle that he called the nucleus. So the answer to the gold foil one was 2. All right. May or may not have just sent a guilty text out to my students. Okay, so again, there's a decent amount that we did in class. And I just want to pick out a few more, let me see, that are just on the tougher side, because I don't want to take up too much time. Let's see here. Let's do excited state. So, a potassium atom in the excited state. First thing I'm going to do is go to the periodic table and find potassium, which is K. And that configuration you see there is the ground state. So what's given to you is the ground state. Your next question might be, what if I don't remember the symbol for potassium? Now go to table S, and you can look it up. And it'll be right there. So no worries. So back to answer choice 3 is the ground state. And excited means I want to take one of those electrons and take it out of one and move it into another. And the answer choice that shows that is going to be answer choice number 4, because it takes one electron from the 3rd energy level and moves it up into the 4th energy level. Don't forget to keep this in mind. This will definitely be on there tomorrow. Excited to ground state. Higher energy state to lower energy state. Any of those explanations explains how light is created for an electron, or how spectral lines are made in an atom. Something like that. Electrons move from higher to lower, excited to ground, something along those lines. You'll get the point. Feel free to text me if you have any more questions. I'll be right back. All right. If there's no questions, I'm going to just end the stream. Feel free to do the castle learning, and we will take this tomorrow. As the request from a student, please don't forget to smash that subscribe button, punch that like button like an excited electron, and